So today we have a problem before us, and they want us to integrate this particular function. All right, this is integral calculus. How do we integrate this function within the given limits? The limit is from 2 to 4, and we have integral from 2 to 4 x squared cos 5x cubed dx, right? In certain functions, there are prescriptions. Depending on the nature of the function, you are expected to choose wisely any of the available methods for integrating a particular function. And in this case, we are dealing with angular function. All right, we have cos 5x cubed. So I want you to be very attentive and see how we will digest this particular problem. So the first thing we are going to do is to understudy what is here underlined. Okay, so using the method of substitution. Using the method of substitution, all right, that means we have to apply some substitutions here, all right. And why this method of substitution, you will be handling differentiation and integration simultaneously. Please, that should be taking note. You will be handling differentiation and integration simultaneously, right? So what we are going to do here is, this is where the issue lies. This 5x cubed is like a function of function. Cos the angle is a function, and then we have 5x cubed is another function in the angular function. So how to substitute is exclusively a skill that you must learn. So what we are going to do is let u equals 5x cubed. This will be easier for me to handle. So if we have got this, the next thing we are going to do is try and find du dx, which is differentiation. That's why I said differentiation is applied here simultaneously with integration. Come on. So what we are going to do is differentiate this. You will have 5. This power will come to the front to multiply 5. All right. Then we have x. Then we reduce the power by 1. Remember some of the problems we solved before in differentiation. All right. At this time, I know you should be familiar with that. So this is x squared. So we said let u equals 5x cubed. And then we try to differentiate this function so that it will help us in our substitution. This means that our du dx is equal to 15x squared. If you differentiate this with respect to x, it will give you 15x squared. Of course, by now we understand that we should all be acquainted with the process of differentiation. All right, make the x subject here. So what it means is that our dx will be du over 15x squared. Okay, so we now consider the expression here. We now say, therefore, our integral from 2 to 4 x squared. So we have cos, in the place of this 5x cubed, we put u times du divided by 15x squared. So this x squared will cancel this x squared, and our standing expression becomes cos u times du, of course, divided by 15. So this expression could be, we decide to bring 1 over 15 outside of the integral function sign. So it looks like this: 1 over 15 integral of 2 to 4, then we have cos u du. Oh, this is very observatory. We can see the clarity and the beauty of the function has come out. This is not difficult for us. It's more like integral identity, all right? So if you integrate cos u or cos x or cos theta, it's going to give you sine theta. So integrating this, what it means is we have 1 over 15, all right? 1 over 15, if you integrate this is going to give us, integrating this, we're going to have sine, all right? Sine u plus u, beginning from 2 to 4. All right, so we finished the integration now, and then since we brought in this u, we substitute. So what it means is that 1 over 15, all right, into sine, then we have 5x squared plus c from 2 to 4. So the next thing, we're going to consider the limit. So we have 1 over 15, major bracket, then we have sine 5 times 4 squared, plus c, and then minus, we have sine 5 times, this is 4 cube, this is 2 cube, all right, plus c, close the bracket, and then we have that. So what we have here, the result is going to be 1 over 15, and then we have sine 320 degrees, all right, plus c, minus sine 40 minus sine c. So sine c we take away plus c, and then what we have becomes 1 over 15, all right, then sine 320 is minus, I think we have 6, 9, then 2, 8. Of course, then we have minus sine 40 degrees. Sine 40 degrees, that's going to be, it's going to be 0.64, I think 0.6428. Then we close the bracket. Okay, so if we work on this minus, that means we're going to add. Okay, so if we add here, what we are going to have is 8 will be 6, and then that's going to give us 5. Then this is going to give us 3, then we have minus 1. All of this divided by 15. So the result is equal to minus 0.089. Then we have 0.4, and then that's going to give us minus 0.12. That's going to give us 0.9 to 2 decimal places, because from the original question we were told that we should leave our answer to 2 decimal places, and this is what it provides. I hope somebody is learning something. Give us a thumb up, share our videos, and then escalate our learning station, for the best is yet to come. See you in our next class.